hope you all have been enjoying .NET Conf so far. My name is Cecil Phillip, and I'm going to be with you for the next couple of hours or so, introducing the next few guests that we have on. But before we do that, I definitely do want to remind you, as you're enjoying the rest of the conference, please make sure you check out our swag. We do have digital swag. So if you go to .NETconf.net/swag, there's tons of really cool digital swag for you to check out. There's a really cool Visual Studio theme, VS Code theme in there for you to check out. And there's also our technical treasure hunt too, where there's tons of prizes in there. Lots of great stuff for you to get. So please make sure you go ahead and check that out as well. Now, that being said, I want to go ahead and introduce our next guest that's coming up. We're going to have Jeremy. So Jeremy, he is a Azure software architect, and he's going to be talking to us about some of the new and improved Azure SDKs for .NET. So Jeremy, why don't you go ahead and kick it off for us?
Thanks, Cecil. And it's Jeffrey, not Jeremy.
Oh, I'm sorry. I apologize. I thought I said Jeffrey.
All right. And you can see my slides now? Yes? Or no? Yes, there you go.
Yes.
Okay, better. Thank you. Hi, everybody. I'm going to be talking about the new and improved Azure SDKs for .NET. I am Jeffrey Richter. I'm a partner software architect on the Azure SDK team at Microsoft. Some of you might be familiar with me from some of the books that I've written in the past. I did some Windows Runtimes books, some .NET books with C#, and a bunch of Windows books. Also have some contact information in the bottom left. Most recently, though, I did a video series on how to architect distributed cloud applications. It's a 6.5-hour long free series just on YouTube. And here's a link to go to for that, and I would encourage you to check that out. A lot of the principles and things that I discuss in that series affected the design and architecture of the Azure SDKs that I'll be discussing in this presentation. So the Azure SDK team was created just over 2 years ago within Microsoft, and we had several goals for the creation of this team. The first goal is that there were a lot of Azure service teams, and they were building client libraries or SDKs for customers like yourself to use, but every service team had their own way of doing things. And so there was very little consistency. It didn't look like Azure was a holistic developer platform. So that's why this team got created 2 years ago, was to say, let's look at all the Azure SDKs and let's have them be idiomatic, which means if you're in C#, we use the C# idioms that are there, like properties and methods, and it's object-oriented, and it's virtual methods, and so on. And if you're in some other language, we do the proper thing for that other language. One of the things Microsoft has gotten feedback on in the past is that our Python libraries looked a lot like they were created by a C# developer. And that's because that's what happened. But now our Azure SDK team, we have experts in these various programming languages that we support, and there are many languages that we support, and those developers, they live and breathe in that language and the ecosystem, so the package managers and the way you design code. So it should give developers like you an idiomatic experience when you grab one of our libraries. The next goal that we had was we wanted to make the libraries be consistent, so that the way they do authentication, for example, or the way they do logging, or the way they do send telemetry and so on, there's a consistent experience, and the way you configure those things, retries is another example. And actually, that's what I'll be spending a lot of time on in this presentation, is going through some of these places where we get a lot of this consistency and bring you a lot of features as a customer using our SDKs. We wanted to make the SDKs approachable, so they're very easy for you to get started with them, and I'll show you that on the next slide. They all have a very consistent pattern to them, and then you can start leveraging the Azure services in very short time, like less than a half hour probably for most, maybe even less than that, for some of the services, and then you can gradually grow into the SDK and learn more of its features and parameters and different overloads so that you're fine-tuning the behavior as you desire for your own application. Another thing we focused on very heavily is diagnosability. When you're using one of our SDKs, you're building a distributed system where your application is talking to Azure services. And whenever you build a distributed system, there's a lot of potential for failure. The network might go down, you might have the wrong endpoint, authentication might fail, and so on. A timeout might occur when waiting for a response. So we have focused on this very heavily, and we've built a lot of mechanisms into the SDK so that when failures like this occur, we surface what the problems are, and we lead you in a direction that you can self-correct these things without getting other people involved to get you back on track so you can start writing code and get things working again. It has been a very big, significant part of our push as when we design new features. And then, of course, dependability. We test our SDKs a lot. We do performance testing. We do unit testing. We're adding features. We have an active team that's working on them. We ship new versions almost monthly for each thing. We have a very high quality bar. We avoid breaking changes, not only in the SDKs themselves, but we work a lot with the Azure service teams so that they don't introduce breaking changes, which means we don't have to break anything in the client library. We're not perfect with this. We're doing the best we can with it, but it's getting better over time, and so the dependability should be greatly improving. And we've documented all of this in SDK guidelines, which we publish on GitHub and available for anybody to see, are guidelines that are overall, and then we also have guidelines that are unique to each programming language. So I said that it's very easy for you to get started using our SDKs. So let me give you what the typical code is that you would write to make some service request. Normally, after you download one of our client libraries, and in .NET, you would add a using directive to the top of your source code. Then inside your function, when you want to talk to an Azure service, you would write code to new up some kind of client. Like this could be a blob client or a key vault client, right? Depending on what kind of service you want to talk to, you would download that service's client library, put the using directive in, reference the assembly, of course, and then you new up the proper client. This is usually your starting point to get started with any kind of Azure service in your code. When you new up a client, all clients typically take two things that are mandatory. The first thing is, what is the endpoint for that client that for the service that you wish to speak to? So you would put in here the endpoint. We make you do this explicitly because a point of failure is that endpoint can't be reached, but you're passing the endpoint in, so you have complete control over this endpoint. If something fails to connect, it could be that the endpoint that you passed was wrong, so then you can easily go and fix it, and you know what it is you're trying to talk to. In addition to the endpoint, when creating a client, you must also pass in what kind of credentials you wish to use in order to authenticate. Our client library is shipped with many different kinds of credentials. The easiest one to use when getting started is the default Azure credential. This one analyzes the environment on your machine. It can look at environment variables. It can look if you're logged into VS Code or Visual Studio with an Azure credential. It can grab that stuff and it can use that for doing the authentication. But we do have other credential mechanisms that are available as well. After you've created this client object, you get a reference to it back, which I'll put in the variable client here. And then in order to make a call to the Azure service, you simply use that client, you say dot, and then you call some method. And in .NET, we have async and we have synchronous versions of all the methods. In this example, I'm only showing the async one, but we have sum up without the async suffix as well. And this will call whatever service operation you desire on this client using this endpoint and using this credential. And then depending on the operation, you may have to pass in some additional parameters. Like if you're uploading a blob, you have to pass in a reference to a stream, and that's where it'll read the data from the stream and put it into the blob up on the server. And then typically you will await an asynchronous operation, and this returns to you a response back that you get back from the service. And that's basically it, right? So you new up a client, it has the URL and the credentials, and then whenever you call some method on that client, that method will go to that URL using those credentials to perform that particular operation. Now, that's the simple getting started scenario, and I think we'd all agree this is fairly simple. But we do actually have a lot of stuff that's happening under the covers here that I would like to spend the time on in this presentation. When you new up a client, we internally create a thing which we call the HTTP pipeline. The HTTP pipeline looks something like this. And it's extensible, which means that you can enhance it. And in my demo, I will show how to do this. So on this client, we're calling some method. Internally, that method call is going to run through this HTTP client, which is a bunch of policies that the constructor of the client has created for you and initialized. And the last policy in that pipeline is the transport policy. This is the policy that actually takes the HTTP request and sends it over to the wire to the Azure service you're trying to talk to. And then when the Azure service sends a response back, it goes back to the transport, and then the transport sends the response back up the pipeline and then ultimately returns a value to you. But let's talk about what's actually happening in this pipeline. The pipeline, as I said, it takes a request and it passes it down. And we have a bunch of what we call policies in the pipeline. So the first policy gets hit is the client request ID policy. What these policies typically do is they can mutate the URL or add query parameters or headers onto the request. They usually do not affect the body of the request, although they could. They usually do not. And so they're modifying the URL, the query parameters, and headers typically. The client request ID goes and adds a unique request ID header with a GUID, and that will be ultimately sent over the wire to the service. This way, the service can keep track of your client request IDs, and this can be used in case you need to call customer support to track down, hey, I got a response from the service. I didn't expect what I saw. This was the request ID that I used to make that request. Another policy in the pipeline is the authentication. This one typically adds the authentication header into the request using the credentials that was passed into the constructor when you newed up the client object in the first place. The next policy is the logging policy. This policy will notify you, after you configure this, that a request is about to be sent over the wire. So your logger can know every time any one of our clients is sending about to send an HTTP request over the wire. So you can track all of that. And then you can see what the request looks like with the headers, the query parameters, and everything else. Again, very important for diagnosability and debugging of problems. The next policy we have is a distributed tracing policy. This adds some additional headers for services that support distributed tracing, so that you can track a client request from its origin as it travels through multiple services to get to some other service. That can be treated as a single logical request, even though it's spanning multiple servers. And this distributed tracing policy goes and tacks on that additional information. So now those policies have modified the request. They send the request to the service, and now the service sends a response back. When the response comes back to the client object, the response now walks backwards through the policies. So most of the policies don't do anything to the response, like distributed tracing doesn't do anything. However, the logging policy does. The logging policy will log the response and correlate it with the request. So now in the log, you can see this request created this response, and you have those correlated together. Another policy that's in here is the buffer response policy. This policy does nothing on the way, it does not modify the request, but when the response comes back, this buffer policy will typically read the entire response payload from the service at this point. The reason why this is here and not somewhere else is because we have another policy, which is perhaps the most important one, and that is the retry policy. Because distributed applications are very likely to fail due to some networking issues, like timeouts or the server doesn't reply in time or so on, we have a retry policy in the pipeline. And the retry policy doesn't actually mutate anything. It doesn't mutate the request, and it doesn't mutate the response. This policy instead modifies the behavior. When the request is going down, it doesn't do anything at all. But if we're reading the response, let's say, back from the service, and because of the buffer response policy tries to do that read, if while we're trying to do that read, the network connection fails, then an exception will be thrown. That exception will be caught by the retry policy over here. The retry policy will then loop around and it will reissue the request automatically, sending it back through the authentication, logging, distributed tracing policies, and then issue the request again. So in other words, when you're using our clients and you're making an operation call, you're making a single logical operation call, but under the covers, it might end up being multiple physical operations because of the retry policy here. They all share the same client request ID because this is the logical operation, but each of those physical responses will be logged separately so you can see them. And this allows you to not have to think about retries in your application and makes your application more robust and reliable because we have built this mechanism into the pipeline for you automatically. And then these are policies that we ship with each of our SDKs. But as I mentioned up here in the top left, our pipeline is extensible. That means that you can go and create your own policies by creating a class derived off a base class, and I'll demonstrate that in code in just a moment. And then you can insert your policies into the pipeline. And you can insert them as per call policies, which means they will execute once per the method call, or you can insert them as a per retry policy, which means it will execute once per every retry. And you can pick this whatever is meaningful to you. Whatever you need to be involved with. Okay, so that's our underlying mechanism. Now let me switch over to Visual Studio Code, and I'll demonstrate how this works and how you can tap into it. So the first thing I wanted to do is I want to create my own policy. So in .NET, we have a base class called HTTP Pipeline Policy. And to create your own policy, you create your own class and simply derive it off this base. This one here, I'm just calling the simple tracing policy. And then it has a virtual method on the base class called process async, and I am overriding that virtual method. You see that it receives an HTTP message as input, right? So all the policies in the pipeline, they receive an HTTP message as input, and then they receive this is effectively a pointer, if you will, to the next policy in the pipeline, because your policy has to invoke the next policy in the chain in the pipeline. Inside the HTTP message, there's also the response. So you'll have to return the response back when you're all done. In this very simple demo here, when this gets called, I just have a console write line that says we're about to make a request. I can go and look at the request method. So this will be like a put or a get or a post or a delete possibly. And then I can also get the URI. And again, I'm not mutating these things here, but you could actually mutate them in a policy if you wanted to. Then I go and call the next policy in the pipeline, passing it the new message and then this pipeline thing, so it knows how to call the one after itself. And then when this returns, so now I have the response and this is returning back, I will say, oh, I got the response, and we can look at the response status code, like is this a 200 OK or a 201 created? And then I also have access to the original request method and the original request URI, right? So you have all this rich information about what was going up and down through the pipeline. So I've created this class and I've overridden this one virtual method. Now let's go and use it in our code. So here I am inside main, and what I showed you earlier was that you normally create a URI and then you new up some client. In this case, I'm using a blob service client. You pass into a client the URI and you pass into it credentials. But what I didn't show you on the slide is that we have another overload of this constructor. All clients have an overload of this constructor that can also take an options structure over here. And the option structure is how you can modify the pipeline that is being used internally by this client object that you're creating. So to leverage that, I'm newing up a blob client option structure. It already allows me to modify the behavior of the retry policy that's in the pipeline. So I can set the maximum retries to 10, and I can set the delay time to 3 seconds. And in this case, I'm going to turn off the logger that's usually turned on, because instead of using the built-in logging policy, I'm going to use my simple tracing policy instead. And in order to accomplish that, I new up an instance of my tracing policy. That's the class I showed you down at the bottom. And I say that I want it called once per call instead of once per retry. This is an enum that has two possible values. And then on the option structure, I add this policy into a collection. So now my options are all initialized for how I want to fine-tune the behavior of the pipeline. I can then go and new up the client, and I pass those options in over here. This now returns back to me a service client, which is exactly like what I showed you on the previous slide. Now that I've done that, and actually let me step through this. Done that, okay. Now, in this example here, I'm going to use that service client, and from the Azure Storage Service, I want to go and get a URL to a container that's within that service. So I'm calling this function get blob container client. What this function does is it takes the URL that's in the service client and it appends this path to the end of that URL, because this is how the Azure Storage Service works. Containers are created as children, if you will, in the hierarchy of the path. And this is going to return back a blob container client. This is a different client object than the one I had before. But here's the interesting thing to note about it. When I use this parent client to create a child client, the child will inherit the pipeline of the parent. So in other words, all these options that I set up above and I applied them to the blob service client, those same options will flow down and will now be on the blob container client as well. And to prove it, I will now use that blob container client, and I will call this function create if not exists, which will try to create the container up in the actual service. And when I do that, if you look at my debug console down below, you'll see that my policy got invoked. And we see it's a put request. And here's the URL for it. Here's the some container, which got concatenated on because of this. And then here's the response that came back, which is a 201, which is a created. So the service successfully created the container that happened because of our original put operation to this URL. So that's our tracing policy working, and we can see it functioning properly. And then I'll show another example where now, since I've created a container in storage, I can go and get a blob client, and this goes and takes the name of the blob and concatenates it to the end of the URL in order to create a new blob client object. But just as before, in this case, the parent, in this case, which is the blob container client, it has a pipeline, and that pipeline will be inherited by this child client, which is the blob client. And then to prove it, we'll use that blob client, and then I will upload some data to the blob. And if you look at the debug console at the bottom, you can see that it did a put request. So it inherited our options, so it's calling my tracing class object. You can see the sum blob.text was concatenated to the end of the URI, and that the service returned a 201 created from this operation. And so this demonstrates to you how we have this pipeline mechanism, kind of explains how it works and what it does. Also shows you how you can modify the behavior of the built-in policies, like the built-in retry and the built-in logger, and also demonstrates to you how you can create your own policies that do whatever it is you want them to do, like client-side caching or fault injection. There's a lot of possibilities there. And then how you can add them in when you create a client to modify the pipeline's behavior, and then how the pipelines get inherited by the children so you get consistent behavior throughout. All right, so that's my demo and my slides. I will now take any questions that people might have.
All right, sure. Thank you so much, Jeff, for that presentation. Why don't we head over to the tag board and we'll take a look at some of these questions that folks have. I know we have a couple of minutes, but I first wanted to shout out Peter Stacy on Twitter. And Peter here is showing off some of that .NET swag that we have. And so he printed this off a little while ago. So just wanted to show that to everyone really quickly. And remember, you can get swag if you head over to .NETconf.net and you head to our swag page. And we have lots of really cool swag like this that you could check out. Now, questions. All right, let's take a look at Charlotte's question. So I'm going to click on Charlotte really quickly. And this one says, can we use that XYZ client object with a using statement?
Well, it's more of a .NET question than anything else. It's the name of a class. So I know they added that feature in .NET where you could say using console, and then you can just call write line everywhere. But it wouldn't know what instance. That only works for static. So the answer would be no. Oh, do you mean using a statement for calling dispose? If that's what you mean, then the client objects are not disposable, so there's no need to do that.
Okay, great. Yes. All right, next question. I'm going to check out Sergio's question. And Sergio is asking, I noticed that a web application service can generate more than one instance. Does this mean that a copy of the website will run simultaneously on another server? If so, what will happen to signal our users who are connected into different servers?
Well, this is not really related to the conversation at all. But yes, if you're running multiple instances of the web application service, then your code will be running on multiple instances. And what impact that has on SignalR is not my area of expertise.
Yeah, I don't think that's so much a security question. Let's see, what else do we have? I'm going to click on this one. Right, and so this question here is asking, does MFA work with Azure default Azure credentials when debugging with VS? I know there were some issues in the past.
This would also be probably better asked on our GitHub repo, where our security person can go and respond to that. I do know that we have a credential. I do know there were some issues, and I know that we were fixing them. I don't know what state that's in. So I think I'd be better off not being the one to attempt an answer on that.
Okay. Looks like we have a really good comment here from Patrick as well. Patrick is saying, the new Azure SDK is really well architected. And Jeff is explaining it and the thoughts behind it very nicely. So definitely appreciate that, Patrick. Appreciate the sentiment. Do we have any more questions that we could ask you? No, doesn't look that way. Like the rest of these questions are not related to your talk. So with that being said, Jeff, I
have a few more things I could say then.
Sure.
So I didn't think I'd have time for this, but another part of our design is that the pipelines are immutable, and that all of the policies in the pipeline that we ship are also immutable. And the benefit of that is that means that multiple threads can be using a single client and with its pipeline all simultaneously, and we don't take any locks or do any kind of thread synchronization, so the performance is really good, and that is guaranteed to work. That being said, and even when a pipeline is inherited by the children, they're really sharing pipelines under the covers because they're all immutable and thread safe. So that means we're using memory very efficiently, and because they're immutable, there's no locks, and so performance is very high. And that being said, one policy in the pipeline actually is mutable, and that is the authentication policy. And the reason why we allow that one to be mutated is that it allows you, the customer, to be able to roll over a password or to refresh a token in the policy. But we make sure that that refreshing or updating is done in a thread-safe atomic way. So we do take a lock over the update, but then we release the lock right away. And that allows you to be able to roll over credentials while multiple threads are using these clients simultaneously. One thread can roll over the credentials and everything keeps working. So again, you have very high performance, very efficient use of memory, and the ability to roll over credentials in real time without blocking your application or restarting it, or without having to do any kind of thread coordination.
Got it. Okay. All right, Jeff, we have time for just one more question, and I'm going to ask this one really quickly. This one's from Joe. Joe's asking, what is the best option to authenticate an app service?
I'm not sure what you mean by app service. I mean, again, if this is a service you yourself are building, you have to decide what your own authentication mechanism is that you want to go and use and how you want to manage that. Our SDKs are for authenticating with Azure services, and those Azure services, they define what authentication mechanisms they support, and sometimes that does change over time. A lot of them are supporting Azure Active Directory today, for example, and then they didn't used to a few years back.
Got it. Yeah, the way I kind of read that was, how do you authenticate with Azure App Service or Azure Web?
Azure App
And
Service.
so that would probably be thinking more about like user authentication, probably.
Yes, I don't know what the authentication mechanism that App Service uses, or if you're building an app that runs inside it, then it's your authentication that you want to use for your app.
Sure. Sure, that makes sense. Well, hey, Jeff, thank you so much. Really appreciate it. And for all of you that are still watching, please go ahead and continue to submit your questions. We're taking questions on Twitter at #.netconf. And also, we're going to queue up our next set of guests. They're going to come on very shortly. But while we do that too, again, like, let me take another look at some of the folks here on Twitter. We have a lot of great folks here that are, here's a picture of Jen. I don't know if you could share my screen really quickly, but here's Jen, again, showing off some more of that cool swag we're getting. And you all could check it out too. It's free. Again, head over to conf.net/swag, and then you can check out some of this really cool swag that we have up here.